some sense. Well, yeah, hi everyone. My name is Lou. On the internet, I'm often known as Toad Pond. Please reach out to me after this. And I work at a company called TLDraw. But what I want to talk to you today is like this is the name of the talk. Okay, this is the name of the talk. Beyond Chat. Bringing models to the canvas. And when I say models, yeah, I'm talking about AI models. Has anyone here heard of AI? Right, okay, good. Someone out there hasn't, and they're gonna be like, what the hell is going on here today? But okay, really what I want to talk to you about, is the canvas, is this. So, but first, oh wow, this screen really makes it dark when it does that. Wait. Oh wow. Okay. Oh, sorry about that. But hey, yeah. To explain this, I want to go 44 years ago, and I will just put on my timer to make sure I don't like drone on for too long. Right, 44 years ago. Do you remember? Let me refresh your memory. All right. So this was the most popular computer 44 years ago, right? And you may notice some things about it. The main thing is the way you use it, well, because bright, dark, right? The way you use it is by typing into it, right? You type into this little chat box, right? So what you do is you type your instructions and it sends you some things back. And then you type some more instructions and it sends some more things back. And what you basically did back then was you actually had a chat with your computer, right? In a way, right? You ask it a question like 3 out of 2, and it gives you the answer. And you give it another message, and then it gives you another answer, right? Right? You know, like we didn't have the things we have now back then. Right? Do you know what this is? Do you know what that is? Yeah. It's a mouse. Yes. And do you know what this is? It's really hard to see, but that is a cursor. Yeah, that's a cursor. It was pointing at parts of the screen. And do you know what these are? Do you know what these are? Have a look. These are overlapping windows. Yeah, not just normal windows, but look, they're overlapping a little bit, right? And the funny thing is, someone had to invent that, right? Like this was the original paper where they defined what a window is, right? And like we take that for granted now. But yeah, it was only many years later that this actually turned into the norm, right? Before then, it was just this like made up piece of research, but it was this Macintosh in 1984 that brought it to the mass market. And it like changed computing forever, right? Forever. They even named an operating system after it, right? Windows is called Windows because it has windows, right? Because it was this new, fancy, exciting idea, right? So can you see what's happened here? I promise this is about AI in the end, right? Can you see what's happened here? We started with text and we moved to this canvas that you can point around with arrows, right? Come on in, perfect time. Hey, do you know what this is? You know what this is, right? This is a phone, like a mobile phone. Yeah, and I had one of these. This was in 2000. And you know the way you use it, it's kind of like a command line, like a terminal. You press up, and then you press enter on the thing that you want to do. And it's basically this like little tiny chat box where you type in texts and then you send the text to someone else, and that's what we call a text, right? The clue's in the name. And you know what happens if you you think that this is going to be the paradigm forever and ever and ever? You like optimize for chat and for text. Of course, we know that's not what happened, right? You know, there was this famous talk from Steve Jobs, it's always Apple for some reason, you know, saying, you know, the main problem with phones is not the top bit, it's this bit. You know, we're optimized for text. And Apple presented this different idea of instead using the screen, the canvas. And you don't point with an arrow, or you point with your finger, but it's still, we're still pointing. You're following, right? Right? Okay, so you see what's happened here. You know, mobile phones started with text, and they moved to the canvas, right? Who knows what this is? Right. This is AI, right? And we're in this current era of chat, right? We, just like those old computers, we have this little chat box at the bottom, and we type in our instruction, right? And we get things back. They all do it, right? Claude does it. Actually, was that Claude? No, that's ChatGPT, Claude, Gemini. They all do the exact same thing. You know, sometimes there's something a little bit that there's some little feature that escapes chat, like Claude artifacts, but it's still kind of like you're still stuck with this chat interface here. You know, like sometimes, yeah, you can upload an image to ChatGPT, but it's like, it's so small, right? It's so small. It's like this third-class citizen, right? You can't interact with it. You can't point at it. It's just this tiny little thing. You're like, you have to be really wordy. It's like, hey, you see that shape second from the left in the middle row, not including the slightly misaligned one. Wasn't, you know, like, come on, just point. Anyway, sorry, just ranting again. Okay, so this is what happens nowadays. Just to recap. When we interact with an AI, when we use an AI product, we ask it a question, we get something back, and we say send it another message, and then we get something back, and then we send it another message, and then we get something back. And you have you have to fact check the answers. So make sure you Google the real answer to that one. Anyway, stupid. Right. So. So this is what's happening, right? We're in this, there's this paradigm of text. There's this paradigm of text. We have text. And then, well, actually, we're still in the text era, right? We're still in the text time. We haven't moved to the canvas time yet. And can we go beyond chat in AI? I don't know, right? Well, luckily, I work at TLDraw. And yeah, we build, I'll show you in a second, like we build Canvas, a Canvas SDK, a Canvas library for other people to build their own Canvas products and whiteboard products. So we have to solve lots of problems around using a canvas, making it fast enough, making it work multiplayer. And of course, you know, one of those things we're now asking, we're trying to figure out is how does this work with AI models? And I think this is at the point where I'm going to ask Hugh to come and hold this. Yeah? So, yeah. You just stand there, perfect. Wonderful, isn't he good? All right, a round of applause for Hugh. Okay, so yeah, like, am I close enough? You can, yeah, okay, excellent. So, you swap hands if you need. Yeah. Or just set up a rotor. Okay, I need to keep going. Right. So what I'm going to show you now is like this flurry of demos and experiments that we've been working on. Some of them may work, some of them may not, but I think either way it should be interesting. So yeah, like TLDraw is this canvas library. We have all the things like you'd expect, like arrows, like, let me show you this. It has this like really like gloopy, can you see that? Can you see how gloopy that is? Right, and obviously like everything, you can interact with everything, and it works really nicely. Do you see like the heart? Do you see how the dashes like just stay lined up with where the, can you see that? Yeah, and if I rotate, you probably can't see, can you see that my cursor is rotating too? And like the shadow is counter-rotating. So it's always, yeah, the sun, anyway. So, and let me show you this, right? Like the arrows can get really curvy, and if I rotate this, then it like hugs it at the right place. Oh yeah, do you see that? Anyway, yeah, so I could keep going. So the other thing is that you need to know for this next thing I'm going to show you is that the canvas is made out of web stuff, right? So everything on the canvas is not, it's not like a custom renderer. Like I could actually open up my little console and say like this is like, I don't know, this is a link, that's like an H2, that's a paragraph, that's a span, you know, etc. So you can like put things like YouTube elements in here, and it all works as well, like blah, 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 blah. This is important, I promise. I better pause that, right? Because, okay, yeah, so on the 14th of March, 2023, like the vision models were kind of available to try for the first time, right? And OpenAI put out this specific example where they had this little this little like crappy drawing of a website. They gave it to an image model, and it produced this crappy website, right? Just from the photo. So there was some people in the community and also us in-house who experimented with this idea. Well, I can draw like a little app. I can draw a little app on TLDraw. I can even do like motion lines. You know, I can do these motion lines, you know, to show it's not part of the app. It's showing how they should behave. So now, thank you. Now let's see, right? If I select this and then hit, do you see that button at the top? It says make real, right? And what this has done is it's taken a screenshot of all of this and sent it off to and sent it off to, well, the top one is going to OpenAI, the bottom one is going to Anthropic, and it may or may not work. Let's see, right? Okay, right, okay, wonderful. OpenAI's got it, okay, it's slightly different layout here, that's cool. All right, and it's, whoa, I find that Claude embellishes it a bit more, you know, hover to bounce. I think I prefer that one, if I'm completely honest, right? And the fun thing about this is that, you know, once you've sent something to one of these models, it's not just going to send it back to you and then that's the end, right? We actually have this kind of feedback loop going on. And let me show you. So here's like one of the earliest examples we tried, right? What we've got is just like a little, I don't know, review box or something like that. And we'll see when is it going to work? Ah, interesting. Claude really likes to embellish things, but I like it. And we have a ChatGPT one. Okay, so it looks like it's done it correctly. Can you see the problem? Can you see the problem? Look, can you see the problem? Right, you see where the button is on my drawing? On the right, but it's done it on the left. And I cherry pick this because it nearly always gets it wrong. So like this button right here, you know, that's supposed to be there. So what I can kind of do is say like, yeah, move this, please. You know, and we'll see if this works, right? Because this is all like web stuff, I can just draw on top of it, you know? Like, or I can draw on top of it, I can put things behind it. It doesn't matter, I can like annotate it however I want. And we'll see if this works. No, it's failed, right? So what I find is a bit of, and I'm gonna draw like a little, like something like this. Right, like that. Yeah? Okay, now let's try. So I'm going to select that and make sure I'll select all of that and select all of that and make real. I'm going to hit it like a few times and we can just see like what the win rate is essentially, right? Okay, so let's see. We've got 2 fails already. We already knew about those. Okay, we've got this one moved to the right side. OpenAI is looking like the winner so far, yeah. Okay, so you see Claude goes with a bit more like creative liberty. But I find that OpenAI is sometimes like more like, you know, by the books. Anyway, so that's just my advice. The other thing that we realized very quickly is that you don't just have to draw it once, right? You could actually draw it multiple times in different ways, you know, something that you'd like give to a designer or something like that, right? And we'll see how this works too, right? We've got this gallery being drawn with some just like, I don't know, imaginary placeholder images. And let's see if I can actually. Okay, so we've got breakpoints, right, as well. So someone's just going like, okay. The crazy thing is that actually you don't need to draw any UI at all, right? Has anyone here drawn a state chart when they want to figure out how something works, right? So what happens if I give it that? What happens, you know, how will it be different if I just give it the UI? Or what happens if I just say stopwatch, right? We're going to get completely different things based on like the fidelity of whatever we give it. So this is a UI that's been imagined just from a state chart, right? And what we're going to get here is actually we have like we have something that's maybe following the UI more. But actually, I find that this is using the new Claude, right? The 3.7 one. It's going a little bit wild, which is quite interesting. The OpenAI stuck to the UI a lot more there. But let's see what happens, right? So this stopwatch is counting up because I haven't specified like the behavior I want. But in this one, let's see if this one is counting down because it's listened to my state chart, right? And this one down here is just like a random stopwatch. It could do whatever it wants, right? And I actually kind of like it. Right. And let's keep racing on. Like let's just try a couple crazy ones. Like there's no way that works. There's no way that works. Okay, let's see. Can it make TLDraw in TLDraw? And let's just like throw in a game as well. Why not? Okay. Right. Let's see. Oh, I kind of like that one. Right. I kind of like that one. Let's give it a try when it's finished writing all the code for it in the background. Okay. So let's see. I've got my color picker. I can go between any of these. And does it copy to the clipboard? All right, there we go. There's my color. Right. Let's see. Okay. There's no way that worked, right? I'm going to try both of these actually. All right. Let's see. Yeah. And all right. I like it. Let's try this one. Yeah. So I think that one's using Three.js and the other one's using CSS transformations. Okay. Let's see. Did it make TLDraw? Let's see. Pick a color. Draw. So I'll be looking for a job soon. And let's see. We've got a little game here. Oh, nice. All right. So the gameplay could use some work, but it's a good start. So here's one I made earlier today. I want to show you that you can actually do these things for quite a long time if you stick with this feedback loop. So I gave it this, and what it made was this. And I think if I make a camera, okay, it's not managing to get my camera there. Interesting. I wonder if it's like, is there another camera connected to this?
Not to your machine.
Fair enough.
Leo's shaking his head.
Right.
That's a no from Leo.
That's a no from Leo. So, all right, but I want to show you anyway, right? Like, okay, so I also said actually add to these little like gallery photos to the bottom, and interesting, yeah. So it's snapping something, right? And I went on this whole, okay, I got a bit carried away, right? And what I'm going to do is after the talk, when we're having a drinks break, come on and we'll try this out and we'll see if we can just basically tell it to fix it. All right. Anyway, so this is called Make Real. This was this experiment that sort of went crazy and viral on the internet back when vision models came out. You can use it at makereal.TLDraw.com. And we experimented with lots of different ways of putting AI on the canvas. So this one is called Draw Fast, because you can draw fast, and what's happening is that we're using this real-time image model to like create this an image in real time. This is sped up like by 1.5 times. Other than that, it's all happening like as you do it. And what you can actually do is because it's happening that fast, you have this like canvas to interact with things. You can move things around as if you're like dragging parts of the image. Right? I think it's so depressing, right? Okay, here's another example. Like a fish that I'm just dragging up and down, drag the water, and this fish is made up of different parts. So like I can like, I don't know, drag the tail smaller. I think this is way better than just typing out a prompt and using like a chat box, right? And because, in TLDraw you can put anything on the canvas, we just like wired up like a camera feed, and yeah, we have a lot of fun in the office. And I'm looking at my time as well. Here's the problem. Like so far, we're basically taking. I can have this for a second. I can. Ooh. So what we're doing is we're taking the contents of the canvas, sending them to this model, and it gives us back this artifact, right? But each time we need to send something from like we have to be the human, in the middle, making this bit happen, right? But what if we could get the model to like create more canvas, right? And make this kind of feedback loop. And that's what I'm going to show you next. This is the next one, right? So we've been working on this experiment called Teach. And what we're trying to do is to teach the model how to play TLDraw. So here I've got like this prompt shape, and I've typed in draw a snowman, and it's going to do its best to draw a snowman. And this is all using TLDraw shapes. This is not image generation, This is like interactable. And okay, that's very pretty. I can also modify what's already there. So I've said to make it melt, because I'm just hoping that Spring will hurry the fuck up. And And it's going to look at the shapes that are already there. It's going to take a screenshot, and it's going to modify them. And our poor little snowman is getting a bit droopy. Oh, yes, it's slightly minor. Oh, and oh no. Okay, and it's sunny. So of course, I think you can have a lot of fun with this. You can try to get it to draw stuff, and of course, it's better at some things than others. I would say I quite like its pigs. I find its face is a little bit scary. It's very good at structured things like castles. Yeah, and I quite like these robots too. It's been interesting to see how it gets on, but of course, I don't think that's the main use case that people get out of this sort of thing. Like, we've had lots of customers come to us who are working in ed tech, who want to be able to auto-generate learning materials or diagrams, or just, I don't know, when you're trying to quickly brainstorm things. And of course, this is fully interactable. It's plugging in these arrows even when I'm editing the board. Let's see if it can make an imaginary retro board for a meeting. Let's give it a go. I think everyone does retros a little bit different. Okay, that looks pretty familiar. Oh, and it's even made up some imaginary drama for the team. Too many meetings and okay. The interesting thing is, you remember the first thing I showed you? We're taking a wireframe and turning it into a website. I think we realized that actually with this, you can do the reverse, right? You can take a screenshot of a website and then turn it into a wireframe. It's quite conservative about the text size. It tries really hard not to overlap anything. But hey, here we go. We've got a sort of mock Twitter /X. Oh, interesting. It's even. Oh my God! Do you see that? It's seeing there's an image in this tweet, and it's trying to recreate the image there as well. That's pretty good. Okay. I'm gonna skip forward a little bit. So the way this is working under the hood, it's using this middleman format, which is we call an AI-driven format. We're trying to get this Venn diagram of what these models want to do and what they're good at. Sometimes that overlaps, sometimes it doesn't, and we try to steer them together essentially. And I think internally we've called this easy, but we've since released this AI module to let other people try and play with this kind of format as well. Beautiful, easy. So I would just say, I'm just going fully into a new tab here. We have this repo called it's our AI module. GitHub.com/TLDraw/AI, and we're basically putting out this challenge for people to do better than our version. Essentially, our version it's got so far, but we think that other people out there will be lovely bushes will be able to do better. There's another problem, and I want to race through. I want to show you one more thing, right? So far we're still doing this, right? We're still sending a request to the model and then getting back one response. Actually, that's not how most of us build AI tools, right? That's not how things work. It works a bit more like this nowadays, right? You have a request that then goes through another step, you get another request, another request, another request, and then sometimes you have a bit of this, right, as well, and then your agents, Okay, so we made this thing called TLDraw Computer, and I want to show you. This is the final thing I want to show you. This is, I think, the maddest one, the most exciting. So, thank you, Hugh. Yeah. So what we've got here is we've got these components. These are custom shapes. So yeah, you can add custom shapes to TLDraw. We've also got a bit of custom UI. I won't get into the detail there, but we've got these custom shapes, and you can connect them together, or with this little bit here, right? This pokey bit. And if you hit the run button, it sends through the data, and you can combine different bits of data together like this, and they sort of combine. But this is just data, right? It's much more interesting if we add this instruction, which, I don't know, let's say increase by 1, right? And then if I have a 0 here, and I plug it in there, we're going to start making a little computer, right? And this instruction, is like a function, except it's not being run by code; it's being run by AI, right? And I could say all sorts. I could say like increase by 3, and let's see if it can add to 0. But the fun thing is when you do that thing I said just a moment ago, where you like make a bit of a loop, and if I now run this, it will just go. It will just go, yeah, forever, right? And use up all of my credits. So I'm gonna very, very quickly get a button and stop that. And instead of going on forever, it's just going to be whenever I hit this button, it's going to increase it by 1. Boom. Okay, so I'm starting to make a little tool. Like I said, you can change this to anything. Like you can use natural language, right? Because we're using an AI model, and I didn't need to. Okay, great. I didn't even need to tell it what a dozen meant. It's given me a little bit of comments as well there, right? Let's see if it can do it again. I wonder what it will do this time. Ah, interesting. It's stuck on that. I'm just gonna go in and edit this, right? Say 18. I mean, what I can also do is give it something even more sloppy, right? Like if I say like increase by loads, then what's gonna happen, right? Okay, great. It's just added 1,000. Whatever, you know. I think the more interesting things happen when you combine different inputs together. So I've got 2 inputs going into this instruction, right? And it's going to add them together. And you know, like you can try to give it looser data. And okay, in this case it worked. But I think we can go even looser, right? So what I have here is a picture of a drawing of an octopus that I've drawn. And so it might not be clearly an octopus. No, it is. It is clear, because I was going to say if it didn't work, it's my fault. But I think actually the more fun thing you can do is just now the camera's working. I want to make sure the octopus is not in the camera though. Oh no, that went the wrong way. Just delete it. Right. Okay. I'm going to hold this up to me, and I'm going to see if it can like understand. I'm trying to say 2. I'm trying to say 2 to you. Great. Okay. All right. Fantastic. And let me see. I've got a couple here that I wanted to show you. So yeah, this is my recipe maker, my recipe designer when I'm looking for more ideas. I've said, hey, I have chocolate and dry ice, because who doesn't have dry ice in their cupboard? And it's given me this idea. But I recently am trying to go more vegan. So I want to see actually what can I. Yeah, vegan dry ice. Any ideas for foods? Yeah, you're not helping my vegan practices. I would say no. Let's see what happens. Let's see what happens, right? I don't know. Dry ice cheese plunge, right? And let's see. It hasn't really taken on the vegan idea.
Let's make it vegan.
Yeah. And what we're gonna do is get a. These AI models, they really try hard not to kill you. So it has said a warning: do not consume, which is, I believe, why that image is there. Like I said before, you can try stuff with apples too. I'm just toxic waste, whatever. Let's see if that works. Let's see what happens. It's very interesting, like combining together these things which are not supposed to be combined. Okay. Radioactive apple cheese bites. Right, prepare, infused with toxicity, serve. Right, this is, yes, disclaimer, this is a humorous commentary on processed foods. Here it is, right, lovely. So I mean, I assume that's vegan. I'm not, it just seems to be like not taking me seriously at all, though. That's fine. Okay, and so I have this, I have this, which I'm remember what I said earlier, right? You can create these loops. So what we have here is this task at the top. It says, create the name of a random pop song. Don't repeat any results. And we have this list which is populating here with all its, it's just added Uptown Funk with all of its previous results. It's then asking them, is the song about love? And then it's, splitting them up into yes, no, and maybe, because sometimes the world is wishy-washy, and it's collecting up these different results here. And if I leave this like running overnight, which I have done, would not advise, it will then, I'll wake up with like this list of songs about love, songs not about love, and songs maybe about love. You know, and this will go on forever. And we're currently looking at ways of like letting you deploy one of these and just like let it process in the background of your life. What could possibly go wrong? And you know, I've seen people go like really far with these things. So this is what I call my AI slop generator, right? This is for inventing new product ideas. So I've made shades for cats, which is like a little bit like, I don't know, internet humor of like when I was a kid, right? So can I imagine you're on Dragon's Den, right? Can I get any ideas for like new products? So what is going to be the new product? I'm going to ask you to shout something out in 3 seconds, right? 3, 2, 1. Elevators with no floors. Right, and let's see it. We can see it's all whooshing around now. So what it's done here is it's brainstormed 5 names for this. It's not just going for one. We've got multiple steps. It's brainstormed 5 of them. It's going to pick the best. It's like workshopped and then reviewed, and it's actually written a pitch for me that I can go and like bring to an investor. It's also coming up with these different like snappy taglines, picking the best for that as well. Reach new heights, no flaws required. You know, I like how it's just gone with your idea, the flawless elevator, right? You're bang on the money. We even have a product photo, and we have a landing page too, right? Explore the future of vertical transportation. Imagine elevators with no floors. And I've actually given it my preferred color scheme here as well, and it's done a new version of my landing page, complete with the technology testimonials from John Doe, CEO. I never thought elevators could be this exciting. Great energy efficiency, right? Okay, there's one more. I know I'm running out of time, but I really want to I really want to show you this. I had a lot of fun making, I call this battle simulator, right? So earlier on, I really wanted to know who would win in a fight. 1 trillion lions. 1 trillion lions or the sun. And of course, it decided that the sun would win. And it's even created like a commentary.
In a spectacle of unimaginable scale, 1 trillion lions gathered to challenge the might of the sun. These were not ordinary lions.
Okay, so what I want now is I want many suggestions, not just one from the keen beans, right? I want many suggestions of something that could potentially beat the sun in a battle, right? Have a think and shout it out in 3, 2, 1. A black hole? We had another one? Death Star, black hole? What's that? Superwoman? Okay. I'm gonna go with black hole. Someone said you, right?
Yeah.
Who was it? You? Okay. In fact, could you come around here?
You're gonna put me in the... where am I going? Am I getting webcam?
So if we hook that up
This
there,
is just coughing toddler
and
versus
then
nuclear bomb all over.
all right.
It was a meme from...
Okay, yeah, sure, right. Okay, great. So just come stand here. Come stand here. It looks strong, you know. Yeah. And now we're going to see. Just hold still. It needs. Oh, it's not going to get me in, is it? Oh dear. I think we may have confused this. This may go very wrong. Just stand firm. All right, and we're going to hit. There's your opponent, the black hole. And let's see the winner. What? The winner is. No, I need to hit.
In a cosmic showdown, a black hole and a human named Hugh clashed. Black hole, a force of gravity, tried to crush Hugh's spirit, but Hugh stood firm. He charged at the singularity.
I did tell you to stand firm, didn't I? Right, okay.
Because I'm standing very firm.
So here's the thing. I really promise this is near the end, right? So, you know, how do we move, right? How do we move from chat to the canvas? You know, we still don't know. I hope if you take anything from this, I hope you can see how many possibilities there are, you know, especially when you look at bringing a canvas to a product, to a tool, right? But it seems really clear to me if we look at what's possible now, and we also look at the history of computing as we know it, right? This happens again and again and again. You know, we move from the text box to a canvas. You know, this is just what we do, right? This is how we communicate with each other. Has anyone used one of these before, right? You know, it's not text. It's imagery. When you're trying to interact with the real world, we use a canvas. You know, we've always done it. You know, with little arrows to point out things, to annotate things. That's how we work as human beings. You know, that's how we build things, right? We don't use a measly little chat box. You know, this is my favorite sign, right? This is, and maybe that says something about me as a person. Hey, but this is on the top of Cairngorm, this mountain in Scotland, right? This is what tells you, this is instructions with how to get off the ski lift. Because if you don't, go all the way back to the bottom, right? And it's not going to be paragraphs, is it? It's going to be a canvas to show you visually how something works, right? You know, we've done this. Leonardo da Vinci, right, used a canvas for his designs. We even did it back in the cave painting times, right? You know, I don't know about you, but this is how I communicate with the rest of my team. You know, we use drawings, diagrams, all sorts, whether it's something textual or not. You know, it helps to convey ideas. This is a talk I saw by someone called David Corshid. He did every slide was made with TLDraw, right, with these arrows all over the place to communicate his points. Like, if you want to try building things with canvases, I really recommend you go to TLDraw.dev. There's like a quick start guide for how to use our library. It's really fast, I promise. And also, we are hiring. We are so if this looks fun at all, and you're enthusiastic about this stuff, even 1% is what I am, then please give that a check. There's some up there already. There's going to be more going up there throughout the course of this whole year. So thank you very much.
Hi, so as Hugh mentioned, the title of my talk is Few-Shot Consultation with SetFit, which is kind of quite a nice idea for how to simplify your prediction workflows. So a little bit about me. So I'm a senior data scientist at the Stepstone Group, and what we do is that we run different job boards around Europe and America, and like you might have heard of Total Jobs in the UK. So my team works on semantic search, document parsing, and for me personally, I also do a variety of what I call ML engineering stuff, which is kind of like deploying models, helping my team with cloud issues, that sort of thing. And kind of like there's my LinkedIn if you want to connect. Yeah, so for my talk today, kind of like a brief outline. So first, I'll kind of introduce you to kind of why we are doing this, what is SetFit and Sentence Transformer. And also kind of the last bit is a fun experiment I did to extend the capabilities of SetFit beyond text to like images. So kind of like the problem statement is like, how do we have efficient models for real-time semantic search? So for example, if you go land on Total Jobs and you are searching for kind of like a job position, you might say data scientist in London. So this sort of thing is quite easy. It's kind of like almost like keyword search. But what about if you say, I want to work outdoors, preferably for someone rich, then then kind of like a keyword search might not give you the most relevant thing in the world. So so kind of what our team is charged of building is that it has to understand these sort of like non-keyword type queries, but at the same time, because the search, it also have to be very quick and the results must be returned within 500 milliseconds. It has to be reasonably cheap to run because the volumes of searches that we do, and also which means that like first we have to host our own models, because otherwise if we use something like OpenAI, we will kind of be bleeding money. And the second is that GPU, even with your own models, can be expensive, so you will have to use cheaper GPUs. Yes, and then kind of, so once we got past these basic requirements, the two extra things that product asks us after they have seen the first version is that it has to understand the concept of seniority very well. So if you say a data scientist with 10 years of experience, then it should return you senior positions rather than like some sort of junior roles. And then the other thing is that for people who do searches with a location only, we want to be able to kind of classify listings into those that are skilled jobs that you kind of need some training before you can apply for them, and also unskilled that anyone can do. Yeah, so kind of like in terms of like the solution for requirements 1 to 3, it can be solved fairly easily with embeddings based on an encoder type model such as BERT or something from the Roberta family. These tend to be a lot smaller, and they kind of can be run quite fast on like even older GPUs. And we can also pre-embed listings and store the factors in a factor database. So that kind of, which means that when someone do the search, we only need to embed their search term and then do a very efficient factor database search. And then we also have quite an efficient surfing framework called Infinity, and with extra Onyx model compilation, we kind of managed to kind of get the inference times that down to 100 milliseconds for the kind of like core embedding model for the search. The problem comes with like requirement 4 and 5. So in terms of like the seniority, we have kind of like we have 7 different levels in terms of how we classify listings, and to get the labels for queries, we kind of it's kind of like a bit of harder to get to the labels, because we can manually label it, but it's also very time consuming, so we don't have that big of a training data set, and certainly not enough to do something like fine-tune BERT to do it. And in terms of like the skilled and unskilled label, we have in-house Mistral 7B model, which we use it for like parsing for different projects. So that model can return structured JSON file listings, and kind of like a skilled and unskilled is an extra field that it can return. But we can't do that without retraining the model, or we kind of like deploying a duplicate version of that with the extra field. So the second option is quite expensive. And the first option is that like when you retrain the model, you also affect all the other projects that are already using the existing model, which might not be desirable, because you can't really rely on the output until you have tracked it, which is not no, kind of like, so they basically say, no, you can't use it. You can't do that. So this is where kind of like this idea of SetFit comes in. But before going on to what SetFit is, I'll just kind of give you a brief summary of what sentence transformer is, in case you don't know about it. So a sentence transformer is kind of like a paper that came out probably like 5-6 years ago now. And if you go to the documentation, they basically say that it's kind of for training state of the art, like text and image embedding models, and it can, and so the idea of sentence, so kind of like most of the sentence transformer models are these encoder type models, And there's two main types of sentence transformer. So the top is what people tend to use for, say, for example, calculating factors for factor database, and the bottom one is for re-ranking. So a bit more detail about it. So in kind of like this version, you kind of, so you can think of this as like the query, and this is the document, the listings. And what you do when you're training is that for the listings that match your queries in your training set, you want to have them to have a high cosine similarity score, and for those that are not that are different, then you want to kind of like, as you're training, you want it to give out a low cosine similarity score. And once you have trained your model, then you only need like one part of this for calculating your embedding. So you pre-embed using one stack. And then you store that for listings, and you store that in the factor database, and then like this, the users go in here and you embed, and then you calculate the similarity score. So that's quite efficient. And then for this bottom setup, so you kind of like both of these have to go through the network at the same time. So if you think of, so you kind of like, so this means that you can't pre-embed anything, and you kind of need to put both the user query and the listing into it at the same time. And it will give you a score about like how well they match. And what you can do is that what you use the top thing to retrieve a larger set of results very quickly, and then you rank these results using this. So because like this setup, because there's so much more interaction between the two entries, it tends to be more accurate. And so kind of, but it also, because it's so much more expensive to compute, then you don't want to run hundreds of documents through it, because it'll take forever to return. Yeah, so how do we use that concept to build a classifier with few, well, kind of like not a very big training set? So this is kind of where SetFit comes in, and it's quite a nice idea. So first you use sentence transformer to generate pairs of sentences. You can train it and then you encode it. So because when you think of a classification task, you want to say whether kind of like there's for a certain, say for example, like a senior or not senior. If I simplify it as a binary use case, but even if you don't have very many labels per class, what you can do is you can generate a lot of permutations of pairs of your label data. So like a positive with a positive, a positive with negative, etc. You can train, and the idea with SetFit is that you train your model to classify whether the pairs are of the same class, of kind of like the same class or not. So which means that you kind of very easily bumped up your training data set. And so and in terms of like how we get from your text labels into a classification is that we know that we have these embedding models, and we want them to be able to separate the classes. So this is where the sentence transformer fine-tuning part comes in. So as you so kind of you pass it these contrasted pairs, and you generate the embeddings, and you tune the embeddings according to kind of your contrastive loss, so that they nicely separate the two classes. And finally, once you have trained the embedding space, you put a classification head on top. So it can be something quite simple as a logistic regression classifier from sklearn, and it can actually give you a fairly decent result. And in terms of how you actually use the library itself, it's very easy if you know transformers from Hugging Face. It's more or less works the same way. So you kind of load the model from sentence transformers. So kind of like rather than model from pre-trained, just say SetFit model from pre-trained, you have a sort of similar setup with like training arguments. The only caveat being that because like the classification head can be a discrete one, like a logistic regression, but it can also be a multi-layer perceptron or a kind of like a differentiable head. So this is where if you pass in a tuple, then it will kind of let you set a different setting for the classification head if it's a multi-layer perceptron. And then again, you might have kind of be familiar with like the usual like trainer setup from Hugging Face, and then you can like trainer.train and let it run. For my use case, I can basically like finish get a decent result with a A10 GPU in like 30 minutes, something like that. So which is quite nice. And there's kind of like some observations that I found when I was using the library, and kind of it for a lot of models, especially LLMs, if you have more data and like longer training runs, they tend to improve. But what I found is that because this technique is quite sample efficient, even running longer, it doesn't really improve metrics by a lot. So you can see that, like, for example, I kind of like tried 2 different models here, and I tried different number of steps. And you can see that the score goes up a bit, but not by a huge amount. So depending on like what you're looking for, it might not be worth training for a very long time. And then when you want to kind of not overfit, so you tend to use early stopping. But an interesting thing to remember about SetFit is that because it's a 2-step process, you actually fine-tune the sentence embedding first, and the early stopping only work on that. So if you want to kind of early stop, but only if the classification, if the whole system works better, then you kind of need to customize your own training loop. And then also with LMs, you also kind of like, again, you sort of normally assume that a more powerful model will give you a lot better results. And it sort of does, but not by as much as you would think. So this, the first model is like 10 times the number of parameters as the bottom one. And again, the scores are quite similar. So it's kind of like you might, so kind of in this sort of setting, you might want to kind of have a bit of a rethink of your assumptions. And I think this was also quite useful because a smaller model tend to be faster and also easier on your infrastructure. Yeah, and then kind of like you can also have observe like what's going on when you train the model using this sort of contrastive setting. So this is kind of a set of plots I did when I was training the skilled versus unskilled model. You can see that in the beginning of the training, there are 2 classes. So this is a T-SNE plot of the embedding space. So it kind of shrinks down the factors into like 2D. So in the beginning, you can see that the factor space, the 2 classes are very mixed together. But by the end, you kind of have this nice separation. So this is kind of which makes it easy for the logistic regression head or whatever classification type model you want to use to kind of distinguish the 2 classes. Yeah, and then I'll kind of so then kind of like I was thinking about my kind of like on the weekend, and I was kind of thinking, well, we have, beside text embedding models, we also have all these nice vision embedding models. So does this technique work with images? Because it seems like with factors, surely it doesn't really matter. And I kind of so at the first pass, so I just shoved some images into it, but it actually didn't work. It kind of crashed. But after a little bit of debugging, I found that like in the current version of the library, the only thing that stops from using images is that they have a default modal card callback in the callbacks, which kind of relies on certain methods that assumes your input is text, so stuff like word count and length, which you can't do with an image. So because it's not for work, so I just more or less just hack the callback, and I just copy that there and remove the modal card callback. And it actually did run. So I kind of picked a random image data set from Hugging Face. So this is like the beans data set, and apparently you're supposed to classify the leaves into 3 different classes according to which DCs they have. And I only kind of picked 10 examples per class, and I used all the default parameters. And I was quite surprised at like the nice scores I got. I was kind of like, right. Sort of like, I think, so kind of just an interesting experiment. I think so kind of like I shared the collab where I ran it. It does vary a bit. Like, I think I didn't quite manage to set all the seeds in there. So I've kind of, sometimes if I rerun it, it kind of don't give me as nice scores, but it did happen at least once. But yeah, so that's kind of something fun you can also do with it. Yeah, so kind of like, yeah, that's it for my talk, but I've kind of left 2 references where kind of like there's an original paper of on arXiv, and also they have a very nice repo and also a very detailed blog about how it works. Yeah.
I'll make that go away. Okay, we're just going to live with the taskbar. Hey everybody, I'm Sean and Tracey. I'm the head of developer relations at a company called Expanso, and that was the wrong slide to show you. But yeah, so we are the developers and maintainers of an open source project called Bacalhau. It's Portuguese for cod, and it is a distributed workload orchestrator. The fun thing about having a product name in Portuguese when none of you speak Portuguese natively is we all butcher the name. So is there a right way of saying it? Absolutely. Are we able to do it? No, we're not. But it stands for COD, and we'll talk more about that later on. But first, a history lesson. It's actually kind of, I think, almost, what's the word, serendipitous that both Lou and I are speaking about the year 1981 this evening. But yeah, forgive me. Something I want to talk to you about today is that the web. The web is not experienced the same way by everybody. For many of us, the web is this rich tapestry of images and videos and dynamic typography, just kind of flying around pixels on whichever device you happen to have, the ones in your pockets, the ones in your homes, the ones on your desks. And it's no wonder that with such interesting and varied content that the web kind of took over the world in the last 30 years. I can't actually think about the last time I sat down to watch terrestrial television, despite it consuming most of the 90s for me. But for others, the web isn't so much of a visual medium. Specifically those who may have a visual impairment, the web is interpreted instead through a whole host of accessible technologies, most notably screen readers, which take the content that you and I take for granted and can just kind of see and interpret and understand, and reinterprets it in a way that makes it more understandable for those who don't have vision in the same way. And this is great for a whole bunch of uses. When you have text on the website, a screen reader will go through it. It will list out all of the elements on there. It will help you see what's there in a different kind of way. And as far as computers go, this is a fairly simple challenge, like reading aloud what's on the screen. We've had text-to-speech technology since the early 80s, about 1981 actually. And there have been some notable users of such technology. This is Dennis H. Klatt. I guarantee you've heard this man's voice, even if you didn't know it. Does anyone know what he's most notably remembered for? No. Oh, good guess, though. Good guess. Think Brainiac Clock. This is the man who created the voice box that Stephen Hawking used. So he made one of the first speech-to-text systems back in the early 80s as part of the research project. And his voice laid down the foundations for what was the voice in Stephen Hawking's voice in a piece of hardware called the Deck Talk. Interesting thing about Stephen Hawking's voice box is it never really changed. But when you run the same box for nearly 40 years, that thing starts to get troubling. Hawkins was particularly picky about how he sounded afterwards. It was hard enough that he lost one voice, let alone losing his new voice, which he began to identify with. And it was Dennis's voice. In the last few months of his life, Hawking's box was getting really quite rickety, so they worked quite hard to create a software emulator for the hardware that could run on a Raspberry Pi. But at the end, Stephen Hawking's voice ran on a Raspberry Pi, which was emulating the same device that Dennis Clapp put together 40 years before, which is just a nice little segue. I myself have a fair amount of experience working with text-to-speech systems, going way back to 2015 when I was in my 20s and optimistic about life. Now I'm in my 30s and, I'm alive for now. And, I use some of the more modern AI-enabled text-to-speech systems, which had a more kind of organic sort of voice. And we use that to make an automatic version of the Financial Times that you could listen to rather than have to read. We built that because when Boris Johnson announced his leadership race, I was both outraged and surprised. And on Waterloo Bridge, you can't read a newspaper when you're walking across Waterloo Bridge during the lunch hour. It's just too many people, but you can listen to it. And you can listen to it on the tube. The FT is huge, but my ears are small. One of my best qualities, according to my grandmother. Don't read too much into that. But yes, so there's a whole way of using things. And because text-to-speech systems aren't that complicated, really. You take text from an input source, could be a website, could be a book, could be anything that's in a computer. And you generate some reasonably understandable speech. Doesn't have to be perfect, doesn't have to sound like you and I. Intonation is a flair, not a necessity. And that's not difficult because there's only a certain number of phonemes in a given language, the bits that make up the sounds that make up words. And there's only a certain number of ways that these things can be combined, right? So, bucket, all those kind of things. So without too much work, you can have something that sounds decently interpretable without having something that's hugely complex or needs to have a full knowledge of the millions and millions of words and varieties and derivations of words in something like English. But the web is more than just text, as I said. At the top of this presentation, it's a smorgasbord, a bit of color in there, of rich visual content. But to a computer, they don't see things the way that you and I do. We see colors and highlights and tones and darkness and brightness, shapes and edges. But, it's a beautiful vista. But a computer sees this. It's just an array of color values in given channels that are defined within a certain set of boundaries and then being rendered out there to become an image that we can see and interpret. So this could be of a sky, this could be of a cat, this could be the beginning of some random numbers that I put into for a presentation. I don't know, the screen reader certainly doesn't, and I'm looking at it right now. And so that's a much harder problem. Breaking up words into the component parts and devising which sounds should make up those parts is, a smaller problem than trying to describe all of the elements that can make up creation. And so the difficulty of that challenge can lock people out from utilizing the web in the fullest and most active way, which isn't fair. And this isn't a new problem. It's one that people have been trying to tackle for a very, very long time. Back in 1993, so a bit more current, but still 32 years ago, there was a draft spec of HTML 1.2, which enabled developers to use something called an alt tag, which would enable you to put a description of an image, because there were images back then, there was no canvas, there was no video tag, but enable you to put a description of what an image was there so that if there was some screen reading technology, it would be able to utilize this rather than have just kind of blank space as far as the user is concerned, or have some fallback content if the image didn't load. So you've got a sense of what's going on in there. And it's been a part of the web since almost the very beginning, right at the very beginning. And that tag has worked its way through the vast majority of websites, applications, and platforms on the internet ever since. But it's not always utilized. And it's hard to know why people don't use these sort of things. It could be that people just aren't aware of the benefits and the utility of the alt tags. It could be that people just can't be bothered. It could be something in between or a mix of both or whatever. But the important thing here is that it is incredibly useful. And I think the why of people don't utilize these things doesn't necessarily matter too much. The really question should be, how can we encourage people to describe their images and their content so that the most people as possible can benefit from and appreciate them? And for us at Expanso, the question is, well, how can we help do that? And the world hasn't remained static in the last 30 years. There have been huge leaps in computational power, drops in prices for that power, and software that enables us to do things now that even like a decade ago would have seemed incredibly infeasible. I mean, Lou's demo earlier on is kind of, I felt like I watched Doug Engelbart doing the mother of all demos like for the 21st century. It's kind of crazy, right? But that was the sort of thing that, again, 10, 15 years ago was completely fanciful and high thinking stuff. But the last couple of years have been interesting. There's been a big burst onto the scene of large language models, brought to us in the first instance, everyone kind of noticed them by OpenAI with ChatGPT. And LLMs are really quite an incredible piece of technology. When you think back to what a chatbot was like 10 years ago in 2015, it was, maybe you'd interact with it in Slack and you'd say, what temperature is it outside? And it would have some very defined boundaries of like, I think this is the kind of question that I'm being asked, this might match up. And it would say, oh, what temperature is outside? The temperature is Turkey. Because it didn't have any sort of decent intelligence or understanding of what was actually said there, but it wasn't quite for it. And LLMs enable us to have much more natural interactions with conversation, with human language. They're able to take an input, get a sense of the context, and then reinterpret that in some way and give us something meaningful back, as we just saw earlier. And boundless applications, but still text in, text out. Right? Wouldn't it be great if we could take visual elements and put them into an LLM and interpret them in some way that an LLM would have those pixel values that we saw earlier on broken down and interpreted so we could ask questions of it. So we could say to the LLM, hey, I'm looking at this, go and do these things here to it. That's kind of the next big step. And that's something that one of the things you can apply is one technology you can use is a large vision model. You have a large language model, there are also large vision models. And they're not greatly different in their construction to something like DeepSeek or Llama. They're still fundamentally LLMs. But they have a little component that sits in front of called a visual encoder, which takes those images, breaks them down into vectors, basically, that allows the LLM to understand them. And so it kind of gives the LLM a capability of, for lack of a better term, seeing what you're talking about. It can get a sense of elements in a picture, how they relate to one another. And then you as a person utilizing an LLM can describe or interact with that content you've just seen there. So we've kind of souped up almost and given LLMs an extra ability. And that means that suddenly you have a model which allows us to answer questions about visual elements. And that's great. And if you want to run like an LVM locally, there are things like Ollama, which if you haven't tried it out, you want to run local, like large language anything or large anything locally, then go and check Ollama out. Really simple piece of kit, which you just download, pull the models. Big, network charges may apply. Don't do it on your mobile phone. But yeah, it enables you to pull them down, run them locally. But if you're going to try and build something that you want other people to go and do, it's not necessarily the most straightforward thing in the world. Getting a large language model or a convolution neural network or any kind of machine learning model up onto a server for many people to use can be a pain in the backside. There's different kinds of dependencies, different kind of hardware requirements, getting access to the systems you want to run these things on, getting them for the kind of price which makes them doable. That's a pain in the backside, but that's something that Expanso, we're really rather good at. And that's because we have this open source project I mentioned earlier called Bacalhau. Now, yeah, it's very clever, it's very cool, and it has a ton of very neat features, but there's one thing it does very, very well. It takes your workloads and puts them where you want to run them. And it doesn't care what kind of work that it is. It can be a Python script, it can be a large language model, can be, flash animation of a chicken running up some stairs. Doesn't really matter, right? Bacalhau will take it from A and get it to B and lets you run that with the hardware that you want to run it on quickly and securely. And, deploying an LVM is as simple as a single CLI command, which is something that we're going to do. And we do it with something called compute over data. So Bacalhau is Portuguese for cod. So the name is a pun in another language. Compute over data when you think of traditional infrastructure and how systems typically work these days, you tend to have a whole array of users or devices or systems that are generating data. And then that data is taken somewhere, be it logs or user interactions or just images that you want to crunch and understand some sort of way. They move to a central data store somewhere, generally speaking, where they are then processed later on by either some big computer that you have, or in part because you have some application you want to run these certain things on. And that's great when you're starting out. I have built every application I've ever built in that way, starting first. But as that application scales, that gets quite hard, quite slow, quite expensive. If you're running megabytes through a system, fine. You're running terabytes through a system, there are egress fees, there is computational fees, there are storage fees. Bit of a pain in the ass. So one of the things that we've done differently is said, well, what if you can keep that data where it is? What if you can keep that data on those systems and instead push your workload to where the information is there? Run it on those systems that already have that data in place. So instead of moving gigabytes, terabytes, or petabytes around through the system, you can move megabytes of application code to those systems and get back those results as though they had been from a central location. That's what Bacalhau does. And yeah, it's fast, it's cheap, and it's super easy to deploy ML workloads with. So even if you don't have data at the edge, you still have edge locations that have computational power you want to utilize. Super handy at being able to do that. And so, to prove that, a few months ago, we launched something we called the Bacalhau Bluesky bot. It's a bot account that would allow you to deploy arbitrary workloads. So if you have the Bacalhau CLI for interacting with your compute somewhere in the world, you would normally just go Bacalhau job run and then say a YAML file which would describe an application you wanted to run it there. I was like, well, Bluesky has an API. We can abstract that out to an account. So instead of running these things on your system, you can run them via a Bluesky account to run them on our network of available compute, which is good fun. And it was more just kind of an educational piece of, we like Bluesky, we like it because it's open, we like it because we have interesting conversations there, we like it because we can interact with the system and show off, actually, distributed computing doesn't have to be this very hard, technical, complicated thing. I have so many diagrams that I could show you, but I'm not going to because, it's a lot, and it's a lightning talk, right? So it's just going to show you the thing. But yeah, essentially, it would take that job. This was a hello world. It would give me my results. Nice and simple. Couldn't be simpler. And while we're on that, while we're showing this off to people, we were having conversations. People do that in social media. And there are a ton of images on Bluesky, we noticed, but not all of them have alt text. And quite a lot of people don't like when there's not alt text. It's a responsibility as far as most people are concerned, and that's quite right, in my opinion. So we kind of sat back and we had a little think, as we want to do. And we're really good at building and shipping ML applications. We have a whole bunch of compute just kind of sitting there waiting to be utilized. And we have this natty little all that English colloquialisms this evening. With this natty little Bacalhau bot just kind of sitting there on Bluesky waiting for kind of generic workflows. We thought, well, what if we had something a bit more specific? What if we had something that was a little bit more kind of targeted and perhaps even useful, had utility for people? And so yesterday, we launched the Bacalhau alt text bot. Again, this lightning talk was, I think we agreed it 6 hours ago. I saw Hugh had put on LinkedIn that we have a lightning slot. I was like, I launched this thing 20 minutes ago. I can demo that, sure. Time will tell. Yeah, essentially, what we have is we have a Bacalhau network, which has Lava, which is LLAVA, which is a large vision model sitting on our network. And whenever someone posts to the Bacalhau alt text bot, mileage may vary, it will take that image, send it off to our network and say, hey, what's in here? And it will generate some alt text and reply to the account with that alt text there. And we thought we'd run it through some examples. So this is me mother and me sister enjoying a lovely pint of Guinness in Dublin. And they were mortified to know they're on a TV quite so large in front of so many people, but that's why they're here. But this image shows two individuals holding glasses of beer. Guinness is technically beer. And raising them in a toast. Great, quite right. They are standing what appears to be a bar or restaurant setting. Yes. And both are smiling, seem to be enjoying themselves. Quite right, they'd had 2 pints at that point. But that was without a prompt. This is just the LVM at its basic level. We aren't saying to it, hey, this is the scene, hey, here's the thread. We're saying, what's in this image? So already it has an awareness of what's going on there. It's better than having nothing. Better than having nothing, which is kind of cool. And we've had some surprising results. This is a user submitted this image, and not only did it describe the scene quite well, it got the name of the thing. Somewhere in that LVM is an awareness that this is Matera, a picturesque view of the village of Matera in Italy, which is known for its sassy cave dwellings and is UNESCO World Heritage Site. So it's given some information there too. You know, if there's a picture of Matera, then it's probably worth explaining what it's about. The landscape is lush and green with terrace fields typical of the Italian countryside. I'd say, for an LVM out of the box, that is fairly good. And then finally, you know, we thought we'd throw something a little bit interesting into it. I went to a party last weekend and I made a hat for it. I went to a cyberpunk party, a good friend of mine's house, and we got some good pictures in the garden. In this image, there is a man standing on a staircase at night. True. He appears to be wearing a black top hat. Yes. Now, to be fair, there are not many top hats with LEDs in them, so while it is an important feature of that image, I'm not surprised that it wasn't picked out. You know, it could have said that my head was on fire, you know, but it was like, you know what, we're going to be rational, we're going to be sensible. It's definitely a black top hat. Has a beard and a moustache. Yes, I do. The man's holding a small handheld device, possibly a smartphone or a similar gadget. Now, it is in fact a glass of whiskey. So it got that wrong. So it does still make some assumptions and presumptions about people and what they're doing and the context that they're in. In fact, this is not the entire description that Lava will output. You put things in there. It tends to do about 2 or 3 paragraphs where it tends to kind of justify itself. But you can only do, I think, 200 characters on Bluesky. So we cut those down. We say if it's going to be more than the limit, then we're going to just kind of pause that there and do it later on. But, you know, these are kind of some of the examples. But it's not a true lightning talk without a little bit of a demo. Yeah, we've got time. Excellent. Cool. So if I exit this presentation, and I have the bot loaded up here, well, people are actively using it. That's good. Huzzah. Well, let's have a look. Let's see, does it work? So people have been using this in ways we didn't expect. So originally, it was meant as a kind of like assistive bot, where people could put an image online and someone could see that it didn't have alt text, say, hey, I want help with this image, and it was going to at us, and we would go and do that for them. But people seem to be using it to actively ask for alt text as they're posting it. They want to be able to quote things, and they want to be able to upload images and get an alt text in response from the alt text box. So I have work to do when I get home. Again, we launched this 13 hours ago. It's still very fresh. And honestly, I'm not surprised it's still up. We have very good software, but I'm kind of surprised it's still up. No one's really maxed it out yet. So yeah, let's see what this person asked for. So they asked for some text. Now this is an interesting one. People would like to know that there is text in this image, but the prompt we have for the large model is briefly describe this image. So what you tend to get from it is a description. Oh, it's some text on some white paper, maybe newspaper clipping. And let's see if it actually responded to that. Hang on. Threading is slightly broken today. So what I'm going to do is I'm going to cheat around a little bit. Yeah. Oh, to be fair, so the image shows a newspaper clipping with the headline, "Not in Alberta." Below the headline is an article that discusses the proposed new state on Fort Smith Island, which is currently located in Alaska. So whether that's correct or not, I can't remember. But let's have a quick little look. And yeah, okay, that's largely correct. But I think in that case, that person wants more traditional OCR, which again, these models can do. I haven't asked for that. So there's some work to be doing about determining like what kind of content we want for what kind of images there, and maybe some user modes even of like, hey, give me alt text versus hey, give me some OCR or something like that. But again, yeah, let's try something out. So I'm going to upload an image from my personal collection. I haven't loaded any up. Do a selfie. I think that was pretty good earlier on. Yeah, let's. This is a new phone. I don't actually know how to use it yet. Here we go. Right. Terrifying. Excellent. Yeah. Yeah. Whenever I send my partner pictures, the response I usually get from her is Christ. So it's like, I'm glad she loves me. Because I must be scary. So hang on, let's put these on Bluesky. I'm very aware that as far as user participation goes, this is not the most engaging thing right now. Please do feel free to add the Bluesky bot in a second. So let's add that. Let's upload that. I'm not going to add any alt text. I'm going to be a bad actor here, and I'm going to be a little bit neglectful, but it's to prove a point. It's in the pursuit of goodness and science, so it's okay. And that's going to be up any second now. So if I now say to at alt text Bacalhau bot text. It's hard typing with a microphone. There we go. So I'm going to reply to that. And essentially what we're doing on the back end there is we have an application which is just polling the Bluesky API every 10 seconds saying, hey, do we have notifications? If there are notifications because we've been added, then we go through those and we say, okay, great, we've got something we want to work through now. And I should have that in there, I've got it right. Good-o, good-o. So we fired that off, right? So that's, yeah, sorry, audience. I don't know how to do a picturesque look. But then the bot then goes, okay, cool. I have this image now. I need to do something with it. I know that in this instance, because I am the alt text bot, so I'm going to generate alt text for it. Takes that, wraps it up in a YAML file, which I'll show you shortly, and then fires it off to the Bacalhau network that we set up. So we run it through a managed orchestrator called Expanso Cloud. I can show you that in a bit if you like. But essentially sends off, says, hey, you have compute available to you. I know that some of you have GPUs. When you have availability, please go and run this model for me. And when you get the results, send them back so I can do something with it. It fires it off. The job executes on one of the many nodes that we have connected to these things. The results happen, and then we should be good to go. I have a notification on my personal Bluesky account. So let's see if it's correct. Okay, yeah, we can put that on screen. Hurrah! You can never be sure. You can never be certain. Hang on. So let's have a look. Oh, hey, there we go. So that's the thing. So this is what we're saying. You've done it wrong. So this is where it's not built right now for asking things directly for it. You have to reply to yourself, essentially. So I have asked it. I've put the picture up there, and I said, hey, go and tag this for me, right? But we'll fix that. That'll be a new feature. But when it was used, the image shows a person giving a presentation or speech, debatable, but not important. Standing in front of the screen, it displays a social media interface. It was showing Bluesky in the background at the time. On the screen, there's a post with text image which appears to be a screenshot from a story on Instagram. It's presumed a little bit there at the end, but you do get a sense of the scene. And so, yeah, that's pretty much the demo. You know what I'm going to do though? I'm going to fire this up. Hang on. So I can't do it for so the Bacalhau bot doesn't respond to itself, right? Because then you just get this endless loop. But what I can do is respond to you, Lou, with my personal Bluesky account. Hang on. Did it? Yeah. Oh, excellent. Okay, there we go. Right, real-time stuff here. Hang on. Hang on. Now, hang on. What did it say? What did it say? What did it say? What did it say? So, yeah. Give it a sec. When did you put that up? Just now. Oh, okay. It has or hasn't? And yeah, this is something that's made testing quite hard. But because oh, here we go. There we go. The image shows a person with long hair looking to the side with their tongue sticking out. Yes. They are wearing a red and black striped shirt. Yes. The person is indoors. There is natural light coming through the windows. It's nighttime. It's not quite right, but hey, 4 out of 5 ain't bad, you know? Coming through windows that are not visible in the image. So it's misinterpreted lighting there. But again, better than an empty void people can't engage with. And this is an off-the-shelf model. We've done literally nothing to augment this at all, other than ask what's in this image. So yeah, some resources for you all. If you want to play with Lava to generate alt text, I've built a CLI utility called Alt Lava. It's on GitHub. This is actually exactly what we ship to the Bacalhau network. So we say, hey, there is this container, right? It expects these parameters. Please go and run it on the available compute. So I can run this code on my laptop and it will work. Or I can container it up and say, hey, go find me a GPU instance somewhere on the network and go and do it. And it will just make that happen. It actually takes about 3 seconds to spin up the Llama server inside the container. And it does the classification in like 500 milliseconds, which is pretty great. So this thing can already run quite comfortably at scale on a quite not powerful GPU that we have hooked up in those networks. We're not burning through thousands of dollars of cash here. You know, we're talking like on the scale of hundreds for quite a minimal thing. But yeah, that's pretty much it. I do have some other resources for you all. As I say, this was a lightning talk. Oh God, they're so bright. But yeah, if you want to find the code for the alt text bot, then please find it there. If you want to find the code that runs the Bacalhau bots, because there's only one code base. And if you want to find out more about these things, we actually wrote a blog about it yesterday. which will help you with these things. So I appreciate that the AI in your phones is currently searching for QR codes, may struggle to have 3 at one time, but hey, this is a work in progress. You know, that's what we do in the technology sector. Yeah, I've been Sean Tracey, and thank you.